So today I want to talk about Relay, which is a library for data-driven apps using GraphQL. I'll explain a little bit about why we originally built Relay and also share some recent rethinking of our core assumptions when we build applications. So Relay is a client library for using GraphQL, which is a query language for APIs. But GraphQL itself doesn't actually require any client-side framework. In fact, a lot of apps actually access their GraphQL servers just using fetch. In my personal opinion, this is a perfectly fine way of building GraphQL-driven apps. Nothing wrong with this at all. So if using fetch is just fine, why do we need a GraphQL client? So I want to talk about some of the aspects of the user experience that a GraphQL client can help improve. First is load time and perceived performance, especially when we're navigating around an app. So if I've already loaded something and I navigate away to look like a notification or a message and then come back, it doesn't make sense that I'd have to wait for another request to the server. I need to be able to use a local cache of that data so I can render instantly. Then also there's consistency. So whenever I'm loading new data onto one screen, I would expect that if I were to navigate back to a different screen, that I would show that same data. So let's say I'm looking at a story in my newsfeed, and the author of a post just changed their profile picture, and then they added a new comment. So when this happens, we should be able to show the new picture everywhere instead of showing conflicting and confusing information to the user. And the client should feel responsive. User actions should be reflected as soon as possible. So if I click on a like button, that button should be updated right away, even if I'm on a spotty network connection. I don't want to have to wait for the server to come back to me to render something on the screen. And finally, and I think maybe most importantly, is developer experience and effectiveness. While it's true that we can just send GraphQL queries using fetch, the maintainability of that doesn't always scale well to more complicated applications. So similar to how we can declare what a view should look like in React, we can also do that same thing with GraphQL with fragments. So ideally, these fragments are located in the same file as the rendering logic for really easy maintainability as that view evolves over time. And if not the same file, then at least a file right next to it with the same name and the same folder. So it's really easy to spot these things. And just like React components, GraphQL fragments are composable and reusable to build a scalable application. And this modular pattern helps us build complicated yet maintainable applications. Also, GraphQL clients can help us with some more complicated access patterns, like pagination over long lists or handling real-time systems. We wanted to make it as easy as possible to use GraphQL on the client. So, we need a GraphQL client that helps us do all of these things. So years ago, we built Relay to help manage data in our more complicated JavaScript applications. And Relay has been really successful at Facebook. We have thousands of Relay components. And not just on the web, but also on iOS and Android via React Native, across Facebook, Instagram, and Oculus. Open sourcing Relay was also a pretty early success. I think what I'm most proud of from that event was that it sparked this greater interest in client libraries for GraphQL, including simple ones like Loca to more complicated ones like the Apollo client. In fact, those building GraphQL client libraries have become a critical part of the open source GraphQL community. And we're constantly sharing ideas between all of these teams to improve all of our projects. So when we first built Relay, we started with a handful of original assumptions. We wanted to use data from our cache as much as possible. That way, the local machine is going to be fast and the network is going to be slow. We want to avoid the network whenever we could, and when we did have to go to the network, we wanted to send the smallest query that we had to. We also wanted to ensure that the data displayed in each component was always going to be up to date. If we received a payload that updated a view that was currently being rendered on the screen, Relay was going to make sure that that component always showed the newest value. We also wanted to support optimistic writes. So that means whenever we tap that like button, it turns blue right away, but also if anything goes wrong, we can cleanly revert that and make sure the view shows the correct state. But most importantly, we just wanted it to work. Developers shouldn't have to think about when or how data is loaded from the network, or when the cache gets leveraged, or how consistency is achieved. This stuff should all be hidden underneath a simple product API. But since then, the tide has changed for product development, and it's shifted to mobile. Thanks to React Native, React and JavaScript have become useful tools for addressing mobile apps just as much as they have for the desktop web. And Relay is a really natural fit for React Native. This new mobile environment led to a lot of new challenges. We found that Relay was popular with new projects where iterating quickly was really a priority, but it wasn't always performant enough. We found that, especially as we were getting a lot more users on low-end Android phones, those devices just didn't have enough CPU and memory to do the work that we needed to do on the client. And a lot of the logic in Relay was just taking way too long in these low-end phones. So we had to address these performance issues. So we thought, Relay needs to be faster, so let's make it faster. So we really zoomed in. The team zoomed in. We looked at systraces, flame graphs. We investigated what parts of Relay were taking the longest amount of time, and we took a handful of approaches to make Relay faster. First, the team tried memoizing things to avoid repeated calculations. Some attempts here helped out. Others were just way too memory intensive. There's no pure solutions in computer science. There's just trade-offs. And in this case, we were trading better speed for more memory use. And that just didn't seem like the right trade-off on these low-end phones where memory can be very limited. So the second approach that we tried was deferring work. By deferring work, such as syncing data to the disk, we can get it out of the critical path to rendering something on screen. But there's just so many steps that Relay needs to do before it renders that there's only so much that we could defer and get a meaningful increase in performance. And then on the framework level, we tried to strip away anything that we could while still keeping the framework functional. But most of Relay's features are pretty tightly coupled together, so there wasn't that much that could be removed without taking away major functionality. So once we got to some of this low-hanging fruit, it was clear that the wins we were getting were incremental and diminishing. The time to load and display on screen was approaching an asymptote that was not anywhere close to where we wanted it to be. But we knew that we could do better. So it was tempting to think that the ultimate solution was just to optimize Relay. But that's not what we've been working on. There's another approach that we can take to improve performance. And that's to rethink our basic assumptions of how to build a good GraphQL client. So we originally assumed a desktop environment, and we were now really focused on building for mobile devices with React Native. And of course, we've been building GraphQL clients for native mobile apps since 2012. In fact, GraphQL was originally created to help us build Newsfeed for iOS. And since then, our teams have learned a lot about how to use GraphQL in our native apps very effectively. So one of the engineers in our team, Joe Savona, spent a lot of time with our iOS engineering team to learn as much as he could about how we were using GraphQL in our iOS native clients and borrow as much of the good ideas as he could and bring them back to JavaScript. So when we first started on Relay, we thought keeping queries dynamic would give engineers the most flexibility and give them the ability to make performant apps. These dynamic queries, they can be generated on the fly. We were able to rewrite queries to eliminate fields that we had already fetched on the client before to avoid fetching unnecessary data. We could also automatically generate queries based on all the previously fetched data that we'd done before in response to doing a write to the server. That way we would get everything that could be updated. But all this dynamism came at a cost. We had to do runtime calculations, maybe okay for desktop machines that have plenty of ample CPU and memory, but maybe not the right thing for limited mobile devices. So let's take a look at a rough breakdown of where we spend time when we're doing dynamic queries. First, we spend a lot of time figuring out what data is actually needed. So first we have to call all these functions on all of our components, compare it to what's in the cache, and then we can figure out what query we actually need to send to the server. Next, we need to take that data structure that we've constructed and actually convert it into a form that we can send over the network. And you might be surprised, but it takes a non-trivial amount of time to build a string for one of these queries. For our more complicated apps, those queries could be several kilobytes long. And sending these huge requests over the network is not trivial, especially when we're dealing with mobile networks, where upload speed is way smaller than download speed. Then we need to actually parse and validate this GraphQL string on the server. And when we finally get a response back, we use that same original data structure that we'd created in the first step to figure out how to write into our cache. And we noticed that Relay was actually doing a lot more work than was actually necessary by processing the same data multiple times. A client just shouldn't be doing this much work for loading and parsing data. So the good news is that we've seen much better performance from our native clients. We learned from our iOS and Android teams that a lot of this work can be moved from the runtime to build time. But in order to do anything meaningful at build time, we can't rely on queries being dynamically created at runtime. So one way we can move to build time is by replacing our dynamic queries with static queries. So you might be wondering, what's the difference between a dynamic query and a static query? Well, in a dynamic query, we have to evaluate interspersed code in template literals to know what the query is actually going to look like. Then we can print it to a string and send that to a server. By contrast, with a static query, we don't allow any substitutions or string concatenation or anything like that. We leave all branching and substitution decisions to the server as part of the GraphQL language. And at runtime, all we need to do is supply values for variables, and then we've achieved the exact same effect. With static queries, we always know exactly what query strings can be sent to the server without even needing to run the code. Since we know what query strings can be sent to the server before we even distribute or run code, we can go one step further than this. When building our app, we can do some static analysis on our code, extract all the queries we know we might send, and send them to a special endpoint on our GraphQL server that saves these queries and gives back a unique identifier for each of them. And then at runtime, the client only needs to send this identifier, and then the server can look up and execute the appropriate query. So static queries open up a lot of opportunities at build time, which can collectively help us dramatically improve performance. So let's take another look at this timeline of creating and sending a query. So with static queries, we no longer need to evaluate so much JavaScript at runtime. Less time spent building query structure, calling functions from components. Instead, we get static analysis to do all this up front at build time. And with static queries, we can produce that final query string at build time, since the structure is always going to be the same. And of course, with persistent queries, we can basically entirely skip this step, so not including a query string on the client at all. With persistent queries, we no longer have to upload the query string when making a request. Since complicated apps can have some really large queries, and mobile networks can have pretty bad upload speeds, this actually saves a really significant chunk of network time. Also, a server can execute from a query ID faster than it can the equivalent query string because it can cache the result of parsing that query on the server. And since our submitted query strings could potentially be invalid, we always validate them before we execute them on the server. But with persistent queries, we validate them only one time at build time. And now that we're actually getting one of these requests from a known to be valid query, there's no need to validate a second time. All of this makes the network request even faster. And this is actually pretty cool, because as front-end developers, we don't normally think of network or server time as something that we have a lot of control over. But in this case, we did. And with the entire application's queries at hand and some time to spend during development, we can produce code to traverse and write the response into our cache that's optimized and ensures that we don't do any unnecessary work at runtime. So the benefits of static queries go beyond improvements in Relay itself. Since we're typically using Relay in a React Native app, we also need to consider that before Relay code even runs, we need to create a JavaScript core instance and load and parse the JavaScript bundle. Because we know that the first React Native route we know what that first route is going to be when we first open our app, we can also know the corresponding GraphQL query, and we can actually start that network request at the same time that we start the React Native initialization process, parallelizing work and further improving whole app performance. So by doing all this work at build time, we were able to dramatically reduce the amount of work that we were doing at runtime and in turn reap some really sizable performance wins. But of course, everything has trade-offs. We lose the ability to dynamically decide what we're going to build our queries from. We have to introduce this new build step, which can take some extra time at development. But in this case, we think that that additional friction is worth it in exchange for not doing the same work, like literally billions of times, on all of our users' devices. So static queries sound great, but there's one huge problem. And that's that Relay is not designed to work with static queries. In fact, dynamic queries are an integral assumption in every part of the Relay codebase. And if all the features that Relay provides are dependent on queries that are dynamically created at runtime, then how are we going to make Relay do what it wasn't designed to do? So we rewrote Relay. The team went back to the drawing board and basically started over with all these new assumptions in mind. And so for the last year, the Relay team, and my teammate Joe Savona in particular, has been working on a new version of Relay that we call Relay Modern. It's redesigned around static queries with performance for mobile devices in mind. It's faster, simpler, and more modular. And static queries aren't the only new thing in Relay Modern. We've also spent a lot of time listening to our users inside and outside of Facebook. We've been working with other leaders in the GraphQL community to include some long requested features and incorporate client-side best practices. For example, Relay's runtime is now modular and uncoupled from React. Support for custom logic for fields like pagination or other query patterns is supported. We have client-side only fields, which lets you extend the server schema to handle data that's only relevant to the client. Our routes no longer know anything about the queries for better compatibility with more routing frameworks. So you can use whatever routing framework you want to bring. A simpler imperative API for mutations helps reduce confusion, and we now support the new GraphQL subscriptions as part of the new spec. So at Facebook, we're continuing to use the existing version of Relay, Relay Classic. However, we're excited to help all of our products move from Relay Classic to Relay Modern. In fact, this process has already begun. We're already shipping real products on top of Relay Modern. One example is the Facebook Marketplace, which is a place for people to buy and sell items in their local communities. Marketplace was originally built with React Native and Relay Classic, but we were able to update this app to Relay Modern while the team continued to build new features. So after converting to Relay Modern, we measured some real performance wins. In fact, for Android users, Marketplace loaded on average 900 milliseconds faster. So that's a double-digit improvement compared to Relay Classic on time to loading the first screen. And that translated to very real improvements in our product metrics, like how much time people are spending in this part of the app, and the number of things they were buying and selling, and all kinds of other engagement with the app. So to achieve this, to achieve Relay Modern, we needed to add something that's relatively unfamiliar to JavaScript developers, but very familiar to native iOS and Android developers, a compiler. But actually, Relay Classic's always relied on a compiler, because Babel's a compiler. But the Relay Babel plugin, it translated queries into direct data structures to be used at runtime, something that looked a little bit like this. In Relay Modern, we also use a Babel plugin, but in contrast, it's much, much simpler. Instead, all it does is delegate to requiring a file, and that file is generated by the Relay compiler. So the Relay compiler produces generated files with similar kinds of data structures as before, but the compiler now has access to all the queries across the whole program, so it can be used as a common point to apply optimizations and new features. So among these optimizations are enabled queries generated by Relay and the code for their responses being as efficient as possible. This is also where we enable persisted queries, since we have access to all the queries in our app at the same time. And another exciting feature is that we can now generate flow types that describe the shape of the response you'll get from your GraphQL server, and we can automatically reference them in your product code. So now underfetching is actually a type error. So we've released Relay Compiler as a standalone NPM module. Now, of course, a compiler typically depends on a runtime, and Relay Modern's runtime provides its normalized store and connects it to the network and the rest of your app. And the new Relay store is much, much simpler than the one in Relay Classic, but most importantly, it includes built-in garbage collection. So compared to the desktop, mobile apps typically have much longer sessions and more limited available memory. So where Relay Classic would continue to draw data into its store, Relay Modern will clean up after itself as much as possible to avoid a never-ending draw on memory. And we have a new API for working with the store and the network that's much simpler. And in particular is the imperative API that we have for mutations. So Relay Classic sought to make mutations as easy as possible by defining what we called fat queries, which is basically everything that could possibly change in response to a mutation. And what Relay Classic would do is it would compare what data had been previously fetched, or what's visible on the screen, to what data might possibly change by looking at that fact query, and then compute dynamically that GraphQL response that would get sent to the server. But in practice, this was usually way more confusing than it was actually useful. And when some data didn't actually show up on the screen that you thought it would, it was not really clear where you would start debugging the problem. So with Relay Modern, that whole system goes away in favor of kind of directly writing the response from your Relay mutation right into the store. So you're now responsible for this yourself, which adds a little bit more onus on you to write the appropriate mutation, but makes debugging way easier, because if you get it wrong, you can see immediately where you got it wrong, and it's user code rather than framework code. So we've also released this as its own separate NPM module, Relay Runtime. But notice that so far, I haven't really spent a lot of time talking about React. So one of the best parts, in my opinion, of Relay Modern is how it defines a separate abstraction layer that no longer relies on React. In fact, the Relay compiler and Relay Runtime NPM modules were extracted on their own, in part because we hope that others will build Relay integrations into all of the other awesome Vue libraries that are out there in JavaScript land, like Angular, Ember, Vue, all the other ones, so many awesome ones out there. But of course, at Facebook, Relay exists to help us write data-laden React components. So of course, we're going to have a module for that as well, React Relay. This produces the new API for creating Relay containers as part of React components. And really all it is like a small amount of glue code between the Relay library, the Relay runtime, and the React APIs. So for those of you who've already started using Relay, you might notice that React Relay is the same module name that we've been using for Relay for the last 2 years. So you might be wondering, where did Relay Classic go? How about that thing? Well, it's still available, but after updating to version 1.0 of React Relay, you'll need to replace your imports of React Relay with React Relay/Classic. And we've actually open sourced our code mod scripts for doing this to help out if you have a bigger code base like we do. And if you've already built something with Relay Classic, you might be concerned about being stuck there with no path going forward. Of course, we had the exact same thought, because at Facebook, we have thousands of Relay Classic components, and we didn't want to get stuck ourselves. So stopping product development to rebuild our apps from the ground up in some new framework is a total non-starter. We don't do that. So we needed to make it possible to incrementally update our apps from Relay Classic to Relay Modern. So in fact, that was exactly the scenario with Facebook Marketplace. We began introducing Relay Modern just before they released this first version of this feature on the Facebook app. So while the team was rapidly building and iterating, Marketplace was already starting to be converted to Relay Modern at the same time. And so they had already launched, and they were in that crucial moment where they were responding to early feedback and implementing follow-up features and moving really quickly while we were undergoing this massive migration project. Here's how we did that. To convert, you just need to incrementally update one component at a time to use a new set of component APIs. This can be done one component at a time without breaking any existing behavior. And that might sound a little bit scary, but keep in mind that Relay only handles data. All your render functions that you've perfected over time, they don't need to be modified at all. And most files, they only require changing a couple function names, and only the more complicated components that deal with pagination or mutations will need a little bit more work. So once the whole tree is converted, then you can pass in the new, more minimal Relay environment, Relay Modern environment, and reap all these benefits of static queries. So Relay Modern introduces new APIs. So what we did is we took these APIs and we built them into Relay Classic. We made Relay Classic forward compatible. So you can use existing components and components converted to these new APIs together without breaking any behavior. And these new forward compatible APIs are found in React Relay/compat. And finally, once you're done with all of that, and you want to produce some smaller bundles, get rid of all the existing Relay Classic stuff, because by the way, the Relay Modern bundles is 1/6 the size of the Relay Classic bundles. We just replace React Relay Compat with React Relay, and now we have a complete Relay Modern app without ever having to stop product development. So of course, all this is available to you today on GitHub. We've been using Relay Modern prod at Facebook since the beginning of the year, and we've been kind of working out the kinks so that you all can use it as well. And last month, my coworker Yuzi Zhang introduced Relay Modern at our F8 conference. Meanwhile, our team was releasing the first release candidate of Relay Modern. And since then, we've been addressing issues and continuing to fix things, and we released a couple more release candidates for Relay Modern. But today I'm excited to announce that Relay Modern will now be recommended without reservation, and we're going to release Relay 1.0. And I figured I'd just do that on the screen. Let's just do this now. Can I pull this over? There it is. All right. Can you all see that? Demo gods. Ship it. Must wait for Wi-Fi. Oh, that's fine. Hey! Now it's live. All right, Relay 1.0, free for everyone. So we're really excited about Relay on the GraphQL team at Facebook, not just because we think that it's good software. Obviously, we think it's good software. We're using it to build some of our most critical apps at Facebook. But mostly because it embodies and enables many of the GraphQL best practices that have been developed over the years at Facebook, from our iOS all the way beginning back in 2012 with our iOS team, but more importantly, across the broader GraphQL community. This has become a much bigger conversation than just that at Facebook. And so we're actually way more excited about the ideas than the implementation of these ideas. So we're going to continue to share and collaborate on these ideas more so than the software itself. That way we can share these with other teams in the community. And I think a great example of this is the Apollo team, whom we work really close with, who recently released the version 1.0 of their awesome Apollo Client app. And that also enables a lot of these same best practices I've been talking about today. So we think that Relay Modern gives us an excellent foundation atop which we can build the kinds of apps that we find ourselves building on top of the increasingly underpowered mobile devices that are on the ends of pretty terrible mobile networks. And it also gives us a really strong set of core abstractions and assumptions that will enable us to explore even more optimizations in the future. But most importantly, I'm excited that we're doing all this work together as a community. We're doing this in the open, and we're doing it with the whole GraphQL community and the React community. And I can't wait to see what else we get to build together. So thanks.